Dawn breaks over the African savanna. A small group of early humans stirs beneath the wide canopy of an ancient baobab tree. Look around. There are no limestone cliffs towering overhead. No protective cave mouths offering sanctuary from predators or the elements. Yet these humans have thrived here for generations, creating ingenious shelters from nothing but what nature provides. The popular image of our ancestors huddled in dark caves barely scratches the surface of human ingenuity. So here's the question that changes everything. What did our species do for the millions of years before we found caves, and how did they create homes from thin air? When we think of prehistoric humans, we all picture the same thing. Fur-clad figures crouched around fires in the mouths of caves, flickering light dancing on rough stone walls. This caveman stereotype is so deeply embedded in our culture that we rarely stop to question it. But here's the shocking truth that archaeologists have been trying to tell us for decades. Caves suitable for human habitation were incredibly rare. And for most of human history, our ancestors lived completely in the open. The evidence is written in stone, quite literally. Archaeological sites across Africa where human evolution began tell a radically different story than the cave-dwelling narrative we've all been taught. At Olduvai Gorge in Tanzania, where some of our earliest ancestors lived 2 million years ago, researchers have found extensive evidence of human occupation. But here's what they didn't find: caves. Virtually none. Instead, they uncovered something far more remarkable: the remains of the world's first constructed shelters. Let me take you back to the very beginning. The story starts with Homo habilis, our earliest tool-making ancestors. Picture them, living on the open plains of East Africa, surrounded by predators, exposed to the elements, facing a challenge that would define our entire species. How do you create protection where none naturally exists? The solution they developed was elegantly simple, yet absolutely revolutionary. Using nothing but stones and branches, they created the first artificial shelters in human history. At a site called DK1 in Olduvai Gorge, the legendary archaeologists Mary and Louis Leakey uncovered something extraordinary: circular arrangements of stones dating back 1.8 million years. Now, you might think, so what? Stones arranged in circles? But these weren't random scatters. These were carefully placed foundations for temporary shelters. Here's what makes this incredible. Some of these stones weighed over 30 pounds. They had been deliberately transported from distant locations and arranged in precise oval patterns, roughly 12 feet across. Analysis of the site revealed that these stone circles once anchored simple windbreaks made from thorny acacia branches. Think about that. 1.8 million years ago, our ancestors were already engineering their own homes. But this was just the beginning of the story. As our ancestors spread across the globe, they encountered environments where even basic materials were scarce. How do you build a shelter when there's nothing to build with? In the windswept grasslands of Eurasia, early humans developed techniques that would make a modern survival expert proud. They learned to read the landscape like a book. They could identify subtle depressions in the ground that could be enhanced into sleeping areas. They recognized which tree species provided the most durable framework materials. They understood seasonal patterns and how to work with nature rather than against it. One of the most ingenious solutions came from the humans who first ventured into forested regions. At a site called Bielsingsleben in Germany, dating to 400,000 years ago, archaeologists discovered evidence of something extraordinary: tree platform shelters. Let that sink in. 400,000 years ago, humans were building elevated platforms in trees. Working with nothing but primitive stone tools, these early humans carefully selected living trees with suitable branch configurations, then modified them to create elevated sleeping platforms. These platforms kept them safe from ground predators and protected them from flooding. The engineering behind these arboreal shelters was remarkably sophisticated. Analysis of tool marks on preserved wooden artifacts shows that these early architects understood weight distribution. They chose branches capable of supporting multiple adults while maintaining the tree's overall health. They wove smaller branches into sleeping mats. They created lean-to roofs using broad leaves and bark sheets, secured with plant fiber cordage that they twisted by hand. These weren't random tree houses built by lucky accident. This was deliberate architecture based on deep understanding of materials and engineering principles. But perhaps the most impressive pre-cave technology emerged in regions where even trees were scarce. On the steppes of Central Asia, where early humans encountered vast grasslands broken only by occasional rock outcroppings, our ancestors became master earth workers. At Kostroma in Russia, archaeologists have uncovered evidence of underground sleeping chambers dating to 800,000 years ago. Now, when I say underground shelters, I don't mean simple holes in the ground. These were carefully engineered subterranean structures. Using wooden digging sticks and flat stones as shovels, early humans excavated oval chambers up to 6 feet deep and 10 feet across. The excavated earth wasn't wasted. It was piled around the perimeter to create additional windbreaks. The interior walls were lined with grass and hide to prevent cave-ins. Overhead, a framework of bent saplings supported a roof of woven grass mats that could be quickly removed for entry and exit. These underground shelters provided incredible insulation from both heat and cold, protected occupants from wind and storms, and were virtually invisible to predators and rival groups. This wasn't primitive survival. This was sophisticated engineering. The sophistication of these early shelters extended far beyond mere protection from the elements. At Geshe Benot Yaakov in Israel, dating to 750,000 years ago, researchers discovered evidence of specialized shelter zones within early human camps. Different areas were designated for different purposes: sleeping zones, tool-making areas, food preparation spaces, and waste disposal sites. We're looking at the first examples of organized domestic architecture in human history. 750,000 years ago, humans were already practicing urban planning. Water management was another crucial innovation. Early humans living in open environments couldn't rely on cave formations to channel rainwater, so they developed their own drainage systems. Excavations at Terra Amata in France, dating to 400,000 years ago, reveal carefully dug channels around shelter sites designed to divert rainwater away from living areas. Some sites even show evidence of elevated sleeping platforms that kept occupants dry during seasonal flooding. These early humans understood hydrology and engineered solutions to control water flow. They were thinking ahead, planning for the rainy season, anticipating problems, and solving them before they occurred. The materials used in these early shelters reveal the incredible resourcefulness of our ancestors. In coastal regions, early humans collected driftwood and seaweed to create dome-shaped huts anchored with stones and shells. In desert areas, they learned to identify and harvest the few available resources: date palm fronds for roofing, dried grass for insulation, and clay-rich soil for waterproofing. Every environment presented unique challenges, and every environment saw unique solutions. One of the most remarkable discoveries came from the Caucasus Mountains. At Dmanisi in Georgia, researchers uncovered a 1.8 million-year-old site that completely revolutionized our understanding of early human architecture. They found evidence of semi-permanent settlements that our ancestors returned to season after season. These early humans had created a standardized shelter design that could be quickly assembled and disassembled as needed. And here's where it gets really interesting. The Dmanisi shelters used what we would recognize today as a modular system. Standardized wooden poles were cut to specific lengths and stored in underground caches. When the group returned to the site, these poles could be quickly assembled into framework structures using pre-dug post holes. Hide covers, also stored in underground pits, could then be stretched over the framework to create weather-tight shelters in a matter of hours. Think about what this reveals. Our ancestors weren't just reacting to immediate shelter needs. They were engaging in complex long-term planning. They were thinking seasonally, even annually. They were preparing for future needs and developing standardized solutions that could be replicated across different locations. This is systems thinking. This is logistics. This is planning on a scale that requires abstract reasoning and future projection. 1.8 million years ago. Now, you might be wondering, when did the transition to cave occupation actually happen? The answer is surprising. It happened gradually, and it wasn't universal. Even after humans began using caves in some regions, many groups continued to prefer constructed shelters. The reasons were entirely practical. Caves were often damp and poorly ventilated. They were frequently occupied by dangerous predators like cave bears and big cats. Many caves were located far from water sources or good hunting grounds. In contrast, constructed shelters could be built exactly where they were needed, near water, near food sources, in optimal defensive positions. Archaeological evidence shows that early humans often extensively modified natural shelters when they found them. At Kesem Cave in Israel, dating to 400,000 years ago, researchers discovered that early inhabitants had completely transformed the cave interior. They created artificial walls, elevated sleeping areas, and specialized activity zones. They weren't simply accepting what nature provided, they were adapting it to their specific needs. The cave was just another material to work with, like stones and branches. The technology of pre-cave shelter construction required specialized knowledge that was passed down through generations. Modern archaeologists who have tried to replicate these shelters using only stone tools and natural materials have discovered something important. It's incredibly difficult without extensive training. Building effective shelters requires deep understanding of local ecology, seasonal patterns, and construction techniques. This knowledge had to be maintained and transmitted across generations, creating some of humanity's first technological traditions. Tool marks on preserved wooden artifacts reveal that different groups developed distinct construction techniques adapted to their local environments. Groups living in bamboo forests developed different lashing techniques than those in deciduous woodlands. Coastal peoples created different water-resistant treatments than inland groups. These regional variations represent some of the earliest examples of human cultural diversity. Not genetic diversity, but cultural diversity. Different groups of humans solving the same problem in different ways, then teaching those solutions to their children, who taught them to their children, creating lasting traditions that persisted for hundreds of thousands of years. The social implications of pre-cave shelter construction were profound. Building substantial shelters required cooperation and coordination among group members. You can't dig a 6-foot deep underground chamber alone. You can't construct a tree platform shelter by yourself. You can't gather, transport, and assemble a modular shelter system without help. Archaeological evidence suggests that shelter construction was often a community activity, with different individuals contributing specialized skills. Some people were better at selecting appropriate trees. Others excelled at weaving grass mats. Some had the physical strength for digging or transporting heavy stones. This cooperation may have been one of the driving forces behind the development of complex human social structures. Working together to build homes helped create the social bonds that would become fundamental to human civilization. Evidence from sites like Schöningen in Germany, dating to 400,000 years ago, shows that shelter construction sites were also centers for tool manufacturing, food processing, and social interaction. The act of building homes together created gathering places where knowledge was shared, relationships were formed, and culture was transmitted. The shelter construction site was humanity's first office, first factory, and first social club, all in one. The abandonment of constructed shelters in favor of caves, where it occurred, often coincided with climate changes that made open-air living more challenging. During ice ages, when temperatures dropped and resources became scarce, the energy savings of using natural shelters became more important than their disadvantages. But even during these periods, many human groups continued to enhance cave environments with constructed elements. They built walls, created internal partitions, and installed artificial floors and ceilings. They were still architects, even when working within natural structures. Perhaps most remarkably, many of the techniques developed by our pre-cave ancestors continued to be used long after cave dwelling became common. Indigenous peoples around the world maintained sophisticated shelter-building traditions that traced their origins back millions of years. The dome-shaped structures of Arctic peoples, the elevated platforms of tropical forest dwellers, and the underground homes of desert peoples all echo techniques first developed in humanity's earliest days. These weren't primitive holdovers from a less advanced time. These were proven technologies, refined over millions of years, perfectly adapted to their environments. Modern survival experts studying these ancient techniques are often amazed by their effectiveness. Military survival training programs now teach methods that were first developed by early humans living without any tools beyond shaped stones and pointed sticks. The fundamental principles remain the same: understanding local materials, working with natural forces rather than against them, and creating modular systems that can be quickly assembled. These principles are as relevant today as they were 2 million years ago. The story of pre-cave human shelters is ultimately a story of innovation born from necessity. Faced with the challenge of survival in open environments, our ancestors didn't wait for nature to provide solutions. They created their own, developing technologies and techniques that laid the foundation for all subsequent human architecture. When we look at the archaeological record with fresh eyes, we see not primitive cave dwellers, but ingenious engineers who solved complex problems with simple tools. They were the first architects, the first city planners, the first engineers. Their innovations, from underground chambers to elevated platforms to modular construction systems, established principles that continue to influence how we build homes today. The next time you see a homeless shelter made from tarps and shopping carts, or a disaster relief structure assembled from prefabricated components, or even a modern modular home, remember that you're looking at techniques first developed by humans who had nothing but stones and sticks. The ingenuity that allowed our species to thrive in environments where we had no natural advantages continues to serve us today. It reminds us that the greatest shelter technology of all isn't some advanced material or sophisticated design. It's the human capacity for innovation itself. Our ancestors didn't live in caves because they were primitive. They built their own shelters because they were brilliant. And that brilliance, passed down through millions of years, is the true inheritance that makes us human.